Could Devuan really be the holy grail of performance? Let's find out. We downloaded Devuan Excalibur 6 in its desktop installer version. Devuan is a distribution based on Debian but does not use systemd. Its first stable version appeared in 2017, created by veteran Unix administrators. When we start the installer, we realize it's the same as Debian's, so it's better to use the live version. We select the language, location, and keyboard layout. The current version of Devuan is Excalibur 6, based on Debian version 13, named Trixie. It uses kernel 6.12 and maintains its own repository. Next, we enter the system hostname, the root password, the username, and the user password. We wait for the installer to detect the disks. Devuan's repository has mirrors of Debian, but with necessary modifications to support the init system chosen instead of systemd. Now we need to select the installation type. In my case, I selected use the entire disk, then chose the disk and finished partitioning. Devuan offers Sysbench, Runit, and OpenRCE as alternatives to systemd. The first version of Devuan was a fork of Debian 8, codenamed Jessie. Then it asks us to enter another source disk. In my case, I added a mirror located in the United States to easily continue the installation. Sysbench is the classic Linux initialization program. It is designed to be small and simple but has been gradually replaced by systemd. Now we need to select the software. By default, it has XFCE as the desktop environment enabled. I will leave it as is and won't install any additional software. Simplicity is to Sysbench what integration is to systemd. Sysbench is ideal for simple workloads, while systemd is better for control. Now we select the init type to install. For this case, I will select Sysbench specifically to check if simplicity affects overall performance. With this, the installation finishes and we proceed to restart the computer so that Devuan starts for the first time and we can evaluate its performance. Sysbench uses classic shell scripts with a sequential imperative execution, while systemd uses detailed configuration files in a declarative way. When the system starts, it asks for the user login. We enter the defined credentials and access the system with an XFCE desktop. After logging in, we proceed to open the terminal to update the system, but the user doesn't have sudo, so we proceed to configure it. Next, we update, and unlike Debian, the B43 Wi-Fi adapter wasn't recognized. The update asks for a CD, so we updated sources and ran the update again. Now it performs the update properly and efficiently. We can install the modules and packages necessary for evaluating the system. The Wi-Fi adapter module was downloaded and compiled, but unfortunately it didn't work. Despite several unsuccessful attempts, the decision was made to continue with Ethernet. The desktop environment, XFCE, was reviewed, featuring simple colors and including most of the applications found in the desktop versions, such as LibreOffice. We installed the Fastfetch package to gather system information, while Sysbench was used to evaluate the distribution on the same computer used in previous videos. Fastfetch was executed, providing detailed information about the kernel, desktop environment, window manager, initial memory usage, and disk installation. Commands were used to gather details such as the distribution name, kernel version, and memory and disk usage. These results were then compared with those from Fastfetch. Sysbench was employed for evaluation, starting with CPU performance. Both single-threaded and multi-threaded operations were tested through mathematical computations. Next, thread and mutex tests followed, designed to assess the system's ability to handle concurrent load and manage resource locking efficiently. Memory read and write operations were evaluated with a sequential benchmark to measure the system's ability to handle memory-intensive tasks. Next, we evaluated disk input and output, prepared the required necessary files, and ran the comprehensive test to determine overall storage performance. We ran the top command to measure the memory consumed by Firefox with one tab, no extensions active, just to observe initial resource usage. We opened a second tab and loaded a video, then a third tab, and finally a fourth, watching how memory consumption increased with each tab opened. We have completed the comprehensive evaluation of Devuan. Now we will analyze the results observed and measured during the tests. Devuan Excalibur uses Debian 13 kernel version. It installed 1,501 packages, uses recent versions of XFCE as the desktop environment and XFWM as the window manager. The initial memory consumption was 1.04 GB, an average value. Regarding disk installation, it was 4.53 GB, which is notable. It does have support for the Y2038 bug, and the boot time without additional firmware was 30 seconds, a very good time despite using Sysbench. In the CPU tests with Sysbench, it reached more than 1,026 events per second, a very impressive value for the tested computer, just like the thread test. The same happened with the thread and mutex tests, whose results were among the best compared to other distributions, suggesting good concurrency handling. In memory read and write, the values were excellent, indicating optimal and efficient memory access management in this distribution. Among the different Firefox tabs open, it consumed an average of 398 megabytes per tab, a typical value for most distributions, with no standout results. For disk read and write, it had 9 megabytes per second for read and 6 for write, which are average values among the evaluations conducted. In conclusion, Devuan has strong performance. For simple systems, it is the holy grail of performance, although there are things to fix, such as hardware detection. That's all. We will continue with distribution tests. If you like the video, give it a like, comment, subscribe, and hit the notification bell. See you next time.